All right, so this is the first set of notes from Chapter 7, which is looking at what a linear system is from a graphing perspective. And a linear system means more than one line at once, and that's essentially how it starts here. A system of equations is more than one equation that we're dealing with at once. And the solution to a system we can visualize is where these graphs are equal one another. And so let's look at this system right here. I have two lines, y equals 2x and y equals x plus 2. First, from a graph, let me just visualize these two graphs. Y equals 2x, I'll draw in green. I can tell from what we've learned in the last chapter that this has a y-intercept of 0 and a slope of 2. So I can visualize this quite quickly. Has a y-intercept of 0 and a slope of 2 means up 2 over 1. Up 2 over 1, or down 2 and backwards 1. Either way, I got enough to draw my one line. Okay, so this is the line, the graph of y equals 2x. And in blue, I'll draw this equation. And so from what we've learned before, we know this is a y-intercept of 2 and a slope of 1. The coefficient of x is 1. So a slope of 1 means up 1 over 1. Up 1 over 1. Up 1 over 1, or down 1, backwards 1. Again, I got enough to draw my second line. So a system, again, is multiple lines or multiple equations at once. And as it says right here, the solution to a system is where these graphs equal one another. And so what does that mean, where they equal one another? Well, it means where they're on top of one another. So that's my solution. That point there is the solution to the system. And so how do you express the solution? It's an ordered pair. I can either say the solution is where x equals 2 and y equals 4. Or I can write as an ordered pair. The solution is 2, 4. So this and this are both the solution from a purely visual way. As well, though, if you have, that was pretty easy to graph. But as well, it's really easy to find the solution using Desmos, which is a graphing app. And again, I highly recommend, if you haven't done so already, that if you have a phone, that you download the Desmos app onto it. It's free, and it doesn't take up much memory, and it's really powerful. And so, for example, if I go to my Desmos app here, if I just type in those two equations, so y equals 2x, there's that first line, and the second equation, y equals x plus 2, it just shows it, and if I just tap my finger on where they cross, it shows me the coordinates of where they intersect, 2, 4. Now in this case, it was pretty easy to visualize them by hand anyways. But again, I do want us to be familiar with Desmos, which is, again, free, really powerful. It's a nice combination. So let me go back to this. I also have some tables here, and I want to get a sense about what a solution means in terms of a table. So if I look here, for y equals 2x, I pick these values for x, put them into the equation, and you get out your y values. So for example, put in a 0. 2 times 0 is 0. Put in a 1. 2 times 1 is 2. 4 and 6. Okay, what does that do? Well, let me do the same thing for the other equation. And so I'm going to put in the same values. Oops. You put in a 0 into this equation, you get out a 2. You put in a 1, you get out a 3. Put in a 2, you get a 4, a 5. And the key is that our solution, we can tell from a table, is when we have the exact same values. So when x equals 2 and y equals 4, we can see our two tables are the same. Our two functions are the same. So many ways of saying it. So essentially, I've now solved this 3 times. Once by looking at tables, which is probably the slowest. Once by creating the graph by hand, which is pretty fast. And also by using Desmos. All right, so let's try solving this. And I'll do this in 2 different ways. I'll do it graphing it by hand, and then I'll use Desmos as well. Now keep in mind, you will not be allowed to use your phone on any test or quiz for marks. And so Desmos is an important idea to understand, but you don't want to over-rely on it. So I want to graph this system here. And like before, I'll graph this one in blue and this one in red. So let's look at the one that I want to graph in blue. How do I graph that? Well, one option is to solve for y. And so, because it's not in slope-intercept form yet. So the first thing I want to do is I'll just write it right here. X minus 3y equals 9. If I want to solve for y, I'm going to add 3y to both sides. So I get x equals 9 plus 3y. I want to subtract 9 from both sides, so x minus 9 equals 3y. And then I want to divide everything by 3. So x over 3 minus 9 over 3 equals y, which I can write as y equals x over 3 minus 3. Now I did that pretty quickly because you can pause the video anytime you want, and we've done this sort of stuff a lot. I don't expect you to be able to do it quite as quickly as I did, but I do expect these ideas to sound familiar. So graphing this function, I can see it has a y-intercept of -3 and a slope of 1/3. And again, that's all. Everything I've done here is straight from the last chapter. So let me graph that function. Let me visualize it. A y-intercept of -3 and a slope of 1/3 means up 1 over 3, or down 1 backwards 3. Either way, there's my graph of x minus 3y equals 9. OK, let me do the same thing for the other equation. Bring this over here. First, let me just copy it out. OK, I want to solve for y. In this case, it's easier to solve for y. I just got to subtract 2x from both sides. I get y equals -2x plus 4. That was it. So now I can see the y-intercept is 4. The slope is -2. Let's remember what that looks like. A y-intercept of 4 is up here. A slope of -2 means down 2 over 1. Down 2 over 1. If I do that again, I can see my solution right there. I'm going to highlight it in green. There's my solution. That's it. I'll go down 2 and over 1 one more time. I'll also draw my line. So there's my system drawn, but the question was find the, to solve it. And so let me answer the question. I've done all the work. So let's state the answer. And again, there's always two ways of stating the answer, either as an ordered pair. In this case, it would be 3, -2. Or I can literally say x equals 3 and y equals -2. Right? This and this all mean the same thing. They're all the solution. And again, notice if I want to go into Desmos in a moment, in Desmos, I can either type these equations here and here, or I can just type my original equations. Desmos can graph any equation that really makes sense in any form. So notice, if I go back to Desmos here, let me get rid of these. If I type in just the first equation as I got it, x minus 3y equals 9. So there's the equation I graphed at first. And here's the other equation, 2x plus y equals 4. There's the second equation, tap where they cross, 3, -2. OK, so notice in Desmos, not all graphing programs, but in Desmos, I can type in any equation. It doesn't have to be solved for y, for example. All right, so let's look at this. First, I gave you a system. So first, what's the solution? And so I can just see the solution. The solution's right there. And noticing the scale of my graph, I can see every grid line is 1. So I can see the coordinates of that point are 3, -1. So that's my solution. The solution is 3, -1. That was nice. So now what are the equations? What's the system? We have the equation. What's the system? So to this, I need to find the equations of each of these lines. I'll start with the one in blue. And if I want to visualize the equation of the line in blue, it's probably most convenient if I stick with it start with slope-intercept form, even though eventually I want the answer in general form. And so at this point, everything I'm doing is just review from chapter 6. Doesn't mean it's easy, but it's nothing really new anymore. But it's good to review. So the graph in blue, to find the equation of the line, I need the slope and the y-intercept. So I can see the y-intercept is -3. The slope I can see is up 2 over 3. So the slope is 2/3. The y-intercept is -3. So the equation of blue is y equals 2/3 x minus 3. Again, y-intercept right there. The slope I drew out. All right, so let me do the exact same thing for the line in green up here. I can see the y-intercept, so is +2. And I just need to find the slope. I can see the slope is down 1 over 1. So the slope of the line in green is -1. Put it all together. The equation for the line in green must be -1 times x plus 2. So I have my equations in slope-intercept form. the question asks for it in general form. So what does general form look like? We have everything on one side. My x term is positive. There's no fractions. So that's really easy to do for the graph in green. So let me start with that one. If I want to put this in general form, if I just add x to both sides to make it positive and subtract 2 from both sides, I brought everything to one side. So I have x plus y, take away 2 on one side. On the other side, I have nothing. There, that's the equation of the graph in green in general form. And what about the one here in blue? A bit more work because of that fraction. First, to get rid of that fraction, though, I can just multiply everything by 3, whatever that denominator is. And so this becomes 3y equals 3 times 2/3. The 3's cancel out. And so you just have 2x. And 3 times negative 3 is negative 9. And now all that's left to put this in general form is to get everything to one side. My x already is positive, so I'm going to leave it where it is. I'm going to subtract 3y from both sides. And so I get 0 equals 2x minus 3y minus 9. And so what I'm going to circle here and here, that together, that's my system that I gave you in general form. Notice pretty much everything I did is continuing on what we did in chapter 6, which we'll notice for so much of this. And I did this pretty quickly because we've seen it before, but it doesn't mean it's easy. For example, all the algebraic work we've done before. And so hopefully it's getting a little bit more clear each time we kind of come back to these ideas. Now again, I'm not going to bother wasting your time, but if I actually type these two equations into Desmos, I will see the exact same system that I gave you in the first place. All right, so the last thing I want to do is without graphing. How can I determine which of these has a solution at negative 2, 5 without graphing? So, I mean, with graphing, especially with Desmos, I could just type that into Desmos, 2 lines, and see, do they really cross at negative 2, 5? Okay, how can I do this without graphing? Well, you have many options, but one thing to remember is if the solution really is negative 2, 5, that means that when x is negative 2 and y is positive 5, the two equations equal one another. Right? That's what a solution means. A solution is where the two equations equal one another. And so if that really is a solution, all I need to do is for each equation, replace x with negative 2, replace y with positive 5, and see if the equations we say hold true. What does that mean? Well, in a moment, I'm going to go to a calculator, and I'm going to type that in, except instead of x, I'm going to type in negative 2. And instead of y, I'm going to type in positive 5. So I'm literally going to type in negative 2 minus 2 times 5, and I'm going to see what it equals. If it equals 12, then I'll check this one. If it doesn't equal 12, then there's no way it's a solution. So let's see. Let me switch to my calculator here. And so I'm now typing in, instead of x, negative 2 minus 2 times 5. And what do I got? Negative 12. Notice the equation should be positive 12. And so I know right off the bat that this first equation doesn't even work, which means really what that tells me is that the line x minus 2y equals 12 doesn't go through the point negative 2, 5. So if it doesn't even go through that point, how on earth can it be part of the solution? So there's no point me going on even checking that. However, what I just did does equal negative 12. For example, what you see right here is the exact same thing I just did, but now it equals negative 12. So this might be the solution to this system right here. What I do now know is that negative 2, 5 does go through the line x minus 2y equals negative 12. But do both lines go through there? So let me check by going to the second equation. Replace that x with negative 2. Replace that y with positive 5 and see if I get 16. If I do, negative 2, 5 is a solution to that system. So let's see. Go back to my calculator and type in this time 3 times negative 2 plus, sorry, not plus, take away 2 times 5, and this equals negative 16, not positive 16. So it doesn't work on this one, which means negative 2, 5 is still not a solution to that system. But perhaps now you can see how it will indeed be the solution to this last system, because all these equations are the same. The only difference is what they equal on the right-hand side. And we've now seen that when you replace x with -2 and y with 5, the first equation equals -12. The second equation equals -16. So without graphing anything, I now know that -2 comma 5 is the solution to only this system. All right, so with that said, all of this chapter, we're going to keep coming back to graphing. And again, you are encouraged to use Desmos at times. Just keep in mind that I want you to understand how to use a graphing device. I want you to understand how those graphs can, what they mean. But I also don't want us to be over-reliant on it. You will never be allowed to use your phone on a test in this course for marks. But it's a great place to start.